In this video, we'll be continuing with linked list. In the previous video, we studied how to insert data or insert a node in a linked list. So in this video, we'll be talking about deleting a node. So first, let's talk about the logic behind it. So if this is our linked list, these are all nodes. I've explained this in detail in my previous video. But if this is my linked list, and these are my empty pointers, empty list 5, 6, 7. So here my start pointer is pointing towards 0 because my linked list is starting from 0. And my empty list pointer is pointing towards 5 because my empty list is starting from 5. So if I want to remove a node, for example, if I want to remove this node, so what's going to happen is when I remove this, when it's out, now this is not pointing towards the first index, but it's pointing towards here, the second index. So this needs to be changed to 2 so that it can point here. Now once this has been removed, I need to add it here in the empty list one. So I will remove B and then write 0. And here I will bring this to the start of my empty list. So it's going to come here. So now my empty list should point towards this value, this position, which is 1. And now this 2 should be pointing towards 5 because now it's going to be connected like this. So this 2 needs to be turned to 5. So this is basically the logic of it. So this was the one scenario where we remove a node from the middle. Now what if I want to remove the starting node? So for example, we have these. My start pointer is pointing towards 0. If I want to remove this, if this is removed, all I need to do is take this to the empty list position like we did up here. And I need to change the start pointer to 1 now. So now it's going to be 1. So these are the two different scenarios that can happen while we're removing a node. So now let's move on to writing its code. So this was my code from the previous video. We made a class node, we made a linked list, and we wrote the function for add node. Now we're going to write one for delete node. I'm going to take all of these as global. And over here, as I explained, I take my current pointer as the start pointer so I can move through the list. I'm going to do this here as well. Then I'm going to ask the user to enter the data they want to remove. So the user will tell what data they want to remove. Like over here, we had A, B, C. So the user will tell if they want to remove A or B or C. So after that, so what's happening here is, as I'm going to run through the whole list, I'm going to keep running till I reach the last element, and the last element is when the next node is -1. I'm going to keep running till I reach the end of the list and till I have not found my data. Because once the data is found, I have no need to run the loop anymore. So as we did over here, this is how we search through a list. So over here, I'm going to take a previous pointer as well. So first, I'm going to change the value of previous pointer to current pointer. And then I'm going to update the value of the current pointer. I've explained this in my previous video as well. So now, once I find my previous pointer and my current pointer, I'm going to check if my current pointer is equals to -1. This means that I have reached the end of my list and I have still not found the data, which means the data does not exist. Data does not exist. Else, now I'm going to check if the data I want to remove is the first node or is it something in between. So if my current pointer will equal my start pointer, that means that it's the first node that needs to be removed. So I'm going to update the value of start pointer. So how this works is that if this is my start pointer at 0, so here I have 1, here I have 2. So what I need to do is I need to update this. Once I've removed this thing, I need to update the start pointer to 1 so that it's going to point here. So to do that, I did start pointer is equals to linked list at the position of the start pointer, which is 0. So linked list at the 0 position dot next node, which is this. So now my start pointer has this value. So this is if it's the first node that needs to be removed. If it's not, I'm going to do linked list previous pointer dot next node is equals to linked list current pointer dot next node. And then I will explain this in a minute. So what's happening here is, let me explain it to you over here. I have A, B, and C. So if I want to remove B, so right now my previous pointer is 0 and my current pointer is 1. Once the data has been found, my previous pointer is 0 and my current pointer is 1. So what's happening here is linked list previous pointer dot next node is equal to linked list current pointer dot next node. So linked list previous pointer is 0 dot next node. So here it's 1. So this means 1. The value of this should be linked list current pointer dot next node, which is 2. So this value of 1 is being changed to 2. This is because now it needs to point over here. So this line of code is doing this. Then we have linked list current pointer dot data is equals to 0. So the current pointer, which is linked list current pointer, which is 1 dot data, originally it stores B. I need to change it to 0 because I'm removing this. I need this to be empty now. So this is changing the B to 0. Then linked list current pointer dot next node is equals to empty list. As I explained here, this thing is brought from here to the start of the empty list pointer. So now this is going to point towards empty list. And then I will change the value of empty list to current pointer because originally my current empty list was pointing towards 5. Now my empty list will point towards 1. So this is how delete node works. So let's try calling it. Let's see if it works. To see if it works. Oops. Let's just delete node. So what data do I want to remove? Let's see. Let's try removing the first one. It's removed. Now to check if it's been removed, I'm going to print linked list position 0 dot data. It should be 0. Oh, it's still giving 1. So I think I made a small mistake here. This whole part needs to be outside the else condition because I am, even if I don't want it to be outside it, I need to add it in the if part as well. So this whole thing needs to be outside else. This is because here, whatever my current pointer is, I need to store the data to 0 over there, and then I need to update the empty list accordingly. So this needs to be outside else. And even if I'm writing it inside else, I need to add it. I need to add it in the if part as well. So let's try running this. I want to remove 1. Now my data at 0 will be at 1. Let's also print empty list to see how it's actually working. Empty list is so my empty list will now point at my index position 0. Let's try removing 6. So now I need to change this to 2. So now here this is going to point to 0. It won't be 6 anymore. And now my empty list will start at 2 because it's 0, 1, 2. So that is how deleting a node works in empty list.